Now let's solve one more question. Find the value of x for which sine of 2 cos inverse cotangent of 2 tan inverse x is equal to 0. Now in this question, we are given that sine of 2 cos inverse cotangent of 2 tan inverse x is equal to 0. Now you have already learned in the previous episodes that 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. So in place of 2 tan inverse x, we can also write tan inverse 2x upon 1 minus x square. So now this equation can be also written as sine of 2 cos inverse cotangent of tan inverse 2x upon 1 minus x square is equal to 0. Now the expression cot of tan inverse 2x upon 1 minus x square can be easily simplified if we can write tan inverse 2x upon 1 minus x square in some cot inverse representation. And by now you already know that tan inverse x is equal to cot inverse 1 upon x. So that means tan inverse 2x upon 1 minus x square can be also written as cot inverse 1 minus x square upon 2x. So this equation can be also written as sine of 2 cos inverse cotangent of cot inverse 1 minus x square upon 2x is equal to 0. And cot of cot inverse x is equal to x. So now left hand side further simplifies to sine of 2 cos inverse 1 minus x square upon 2x is equal to 0. And also from the properties of inverse trigonometric function, you already know that 2 cos inverse x is equal to sine inverse 2x into square root of 1 minus x square. And that means 2 cos inverse 1 minus x square upon 2x can be also written as sine inverse 2 into 1 minus x square upon 2x into square root of 1 minus x square upon 2x whole squared. So now this equation can be also written as sine of sine inverse 2 into 1 minus x square upon 2x into square root of 1 minus x square upon 2x whole squared is equal to 0. And also sine of sine inverse x is equal to x. So now this equation becomes 1 minus x square upon x into 1 minus x square upon 2x whole squared is equal to 0. So now in the left hand side we have product of two expression and the right hand side we have 0. And the product of two factors is 0 if and only either of them is equal to 0 or both of them are equal to 0. That means either 1 minus x square upon x is equal to 0 or the square root of 1 minus x square upon 2x whole squared is equal to 0. And if 1 minus x square upon x is equal to 0, then that means 1 minus x square is equal to 0. And the square root of 1 minus x square upon 2x whole squared is equal to 0 only when 1 minus x square upon 2x whole square is equal to 1. And if 1 minus x square is equal to 0, then that means x square is equal to 1 or x is equal to plus minus 1. And for the second expression, 1 minus x square whole squared is equal to 2x whole square. Now taking 2x whole square to the left hand side, then the equation becomes 1 minus x square whole squared minus 2x whole square is equal to 0. And now a square minus b square is equal to a plus b into a minus b. So that means 1 minus x square whole squared minus 2x whole square can be also written as 1 minus x square plus 2x into 1 minus x square minus 2x is equal to 0. Now the product of these two will be equal to 0 only if 1 minus x square plus 2x is equal to 0 or 1 minus x square minus 2x is equal to 0. Now solving the quadratic equation 1 minus x square plus 2x is equal to 0. Now the roots of this equation are minus 1 plus minus under root 2. Similarly, the roots of the quadratic equation 1 minus x square minus 2x is equal to 0 are 1 plus minus under root 2. So that means the value of x which satisfies the equation sine of 2 cos inverse cotangent of 2 tan inverse x is equal to 0 are plus minus 1, minus 1 plus minus under root 2 and 1 plus minus under root 2. So let's solve one more question. Prove that tan inverse 1 minus x upon 1 plus x minus tan inverse 1 minus y upon 1 plus y is equal to sine inverse y minus x upon square root of 1 plus x square into square root of 1 plus y square. Now in this question, in the left hand side we have tan inverse 1 minus x upon 1 plus x minus tan inverse 1 minus y upon 1 plus y. And now tan inverse 1 minus x upon 1 plus x can be also written as tan inverse 1 minus x upon 1 plus 1 into x. And from the properties of inverse trigonometric function, which you have learned in the previous episodes, you know it very well that tan inverse a minus b upon 1 plus a into b is equal to tan inverse a minus tan inverse b. So that means tan inverse 1 minus x upon 1 plus 1 into x can be also written as tan inverse 1 minus tan inverse x. And in the same manner, tan inverse 1 minus y upon 1 plus y can be also written as tan inverse 1 minus y divided by 1 plus 1 into y, and which is equal to tan inverse 1 minus tan inverse y. Now the left hand side becomes tan inverse 1 minus tan inverse x minus tan inverse 1 minus tan inverse y, and which is equal to tan inverse y minus tan inverse x. And tan inverse y minus tan inverse x is equal to tan inverse y minus x upon 1 plus yx. So finally our left hand side becomes tan inverse y minus x upon 1 plus yx. And also from the properties of inverse trigonometric functions, you already know that tan inverse a upon b is equal to sine inverse a upon square root of a square plus b square, which means tan inverse y minus x upon 1 plus yx is equal to sine inverse y minus x upon square root of 1 plus yx whole square plus y minus x whole square. And after simplification, this expression reduces to sine inverse y minus x upon square root of 1 plus x square into 1 plus y square, and which is equal to right hand side.